Hello, Paul, in the most excellent community of developers with interest in Arduino programming with Python. This is episode number 10, catching up with the series. We were asked to make some project involving data exchange with the Arduino, from and to the Arduino, and I choose to set up some kind of Morse code practice. Morse code practice because it's fun, and we will see LEDs blinking and try to guess what it means. So this will be data sent to the Arduino, and from the Arduino we will retrieve the value of a potentiometer that will allow us to adjust the speed of the word, the speed of transmitting. Okay. In fact, if we take here the Morse system, you know probably that a letter is symbolized by dashes and dots. This is a dash, dot dot, dash. Okay, which is letter X here. Most excellent letter X, like in Xavier. And the duration of a sign, the duration of the gap between the signs, and even the gap between letters, letter A, and later the gaps between the words. All that is related to the duration of the dot. The dot has a duration, and everything is computed, can be computed from this duration of the dots. Okay, so for instance, we can say that the dash duration here is 3 times dot duration. The gap between signs here, dash or dots, is just the same as the dot duration, etc., etc. Okay, and there is even a relation, because the speed is expressed in words per minute. Word per minute. Okay. In the exams, we try to reach a speed of 20 words per minute. Okay, and we can say that a minimum would be 4 words per minute, which would be 15 seconds for 1 word, which is quite slow. Okay, so of course there are also people in the Guinness Book of Records that can reach much higher values, but this is what we should reach is something between those two values here. So we can consider a minimum WPM of 4 and a maximum of 20, which would be just enough for us. And in fact there is a relationship between this word per minute word per minute here which is how much was this? We can say that dot duration or dot length will be equal to 1200 on the word per minute. Okay, which is if we have here the slowest rate 4, it will be 1200 on 4, which is what? 300 milliseconds. Which is 0.3 seconds. Okay, that's about how we calculate all this, and I'll show you the code later about this approach. Let's see first the Arduino code, the Arduino side of the code. If I can find my mouse here. That's it here. Okay, and I change my screen. Here, that's it. Okay, and I just put this here. Or I will hide the Arduino board. The Arduino board is not very complicated. You can see here there is the Morse code LED. Flashes will come here. There's my potentiometer here, and the LED. I put a USB plug cap on it just to make it a little bit bigger, and hopefully we can see it better on the webcam. We'll see that later. Okay, about the code here, I will plug my red LED here on the pin 13. The potentiometer will be on A0. There's a variable for the potentiometer value here. The delay, I think I don't use it. Okay, there are the constants here. I used constants for the blue, green and red pins of the legs of the RGB LED here. Okay, the red, green and blue value, I think they're not useful here, but it's from another code or the tests. Okay, in the setup I just declare here the RGB pins, which are output of course, and I set it off. The 3 legs of the RGB LED are on low. Then I will here declare my morse LED like an output, and of course the potentiometer pin in input. And I begin. Okay, when beginning I will send the current value to the Python code, because the Python code will need this value to initialize the word speed. Okay, as we know, this value will range from 0 to 1023. We will convert it in a percentage and use it to adjust our word per minute. Okay, this will be the initial value here. Then the loop. I arranged my loop here to read all messages all messages incoming or incoming messages from the Python code. So as soon as there is something to read, we read it, and then we act following the instruction. Okay, we have an on here or off command just to light up or set off the LED, the red LED. This will be the flashing LED. If we receive a rate command, means that the Python code on the other side is waiting for a read of the value of the potentiometer. So we read potentiometer and we send it to serial. Okay, and the RGB LED. What will we be used? What will it be used for? Sorry, we'll use it as a feedback. Okay, it will be a feedback color, which will be green if it's okay, orange if it's not so okay, medium, and red if it's not good. And we will use this not on the result on each input, but on the average of the exercise. Okay, so we can light here our RGB LED in those three colors. Of course, I could have sent directly the values from the Python code, but I send here just instructions to light it in red, orange, or green. Okay, if it's red or green, I can use digital white with high, low, low, or low, high, low. If it's orange, I will have digital white for high and low, for red and blue, and analog white. See here, about the half. Normally it would be 127. I tried here to make something more reddish, deeper orange, and the green. And that's it. So what's on the Python side now? Okay, on the Python side, we have, try to make it a little bit bigger. We need time for the delays, random, and serial. We start the serial as usual. I showed you calculations for the principle, the main principle about duration of the dot, the dash, the intersign, delay, etc. I set up all this in a class because it's easier to manipulate afterwards. This class is named speed because it will deal with the speed of the elements that we send. We initialize it in the constructor here, so-called constructor, with the word per minute. WPM will be word per minute. Okay, we have the minimum and a maximum here. Minimum 4, maximum 20, as we saw earlier, and we initialize it at its minimal value. Okay, on the board I will have to turn the potentiometer completely on the left, counterclockwise. We saw that everything, those delays, dash duration, interletter duration, etc., is based on the dot duration, and the dot duration is based on what? It's based on the word per minute. Okay, so I set up here properties, which are called virtual properties. Those virtual properties don't hold a stated value. I hesitate to say static value because it's not a matter of being static or not here. But the value will be calculated when accessed. It means that if I try to access property dot duration, this will be computed on the fly by this first function. A property can have 4 functions in parameters, and the first one will be used for the access. As this function won't be used in another way, I can use here an anonymous function that I call a lambda function. Lambda function takes a self as a parameter and will return 1200 on self dot word per minute on 1000, just to get finally here seconds, because we work in seconds. Okay, and same for all the rest, all the other properties: dash duration, dash dot separator, letter separator, and word separator. They are each computed following established rules. You can have a look at Wikipedia or whatever you like. There are enough documentation about this technology. Okay, this speed, of course, will be updatable. So I have implemented here an update method, which will take as a parameter here a rate. Okay, the rate will be a float here, and with this float we can add to the minimum word per minute. We add the range, possible range, which is the maximum minus the minimum, multiplied by the rate. And this will give us something between the minimum and the maximum word per minute. Okay, we don't need a excessive precision though, so we round at 1 decimal. Okay, for this calculation, I hope it makes sense. If not, you can read again the video at a slow speed until it makes sense. So we initialize the speed by instantiating the speed class here, and we initialize a dictionary, Python dictionary of Morse code. Letter A is dot dash, letter B is dash dot dot dot, etc. Okay, I didn't take all the letters, a few here. The most important one can allow us to write some important words like Xavier, and, free, for, BBF, Polkate, and resist. Why I didn't put the metaverse? Because there are too many letters in it, and would be long. It doesn't deserve. We know what we have to resist to. Not the coffee, for sure. Okay, so in this dictionary of words that could be obtained from a web service later, why not? We will return here a random element of this array, of this list, as they say in Python, with the function getWord. Okay. And we have in the class random we have the method choice that will return us an element of a list, which is exactly what we need. Then we must be able to send a sign. What I call a sign here is either a dash or a dot. Okay, so I made a generic function here that will use duration, which will be the duration of the lit phase of the LED. If I want a dash, duration will be long. If I want a dot, duration will be short. Okay, so I send on, then I do nothing for the duration, then I send off, and then what do I have to send? Oh, I send nothing, but I sleep for the time of a dash dot separator, which we have computed in the speed class. Okay, so this method will be used inside a dash or a dot method. There's a dash function, dash function here. The dash function will flash using the speed dash duration. So I would have used some kind of a decorator, but I don't want to make too exotic things here. So dash will flash for dash duration, and dot will flash for dot duration. How do I choose which method I want to use? Well, I define what I call a code mapper. Code mapper will set the correspondence between dash sign, minus, and dash. You can notice here dash is not a string. Dash is the function dash. Okay, and there are no parentheses, because what we want to do here is the pointer to this function. And for the dot, of course, as we can guess, I will point to the dot function. Okay, I will use this code mapper inside a send what? I will send a code. Okay, a code which will be a dash or a dot, a minus sign or a dot sign here. So if I want to call the right function, is a dash or dot, code here being minus or dot, I can call here code mapper with here in square brackets the code, which will be minus or dot, and point to the right function. As it's a function, I can call the function with double parentheses here. So this will call the right function depending on the code here that is sent. Okay, you can say maybe here code equal equals minus or dot as a string, of course, as a character. Yeah. Okay, that is what I mean. Then what happens when we want to send a letter? The letter here will be A, B, C, etc. Okay, so in the letter we can retrieve the Morse equivalent. Okay. Morse for the letter A here will be dash minus, which is a string, and a string is also a list, kind of list in Python. Okay, so it means that we can loop on this string, and for each element of this string we can retrieve this element, the current element, in code. So for letter A, in the first step of the loop, code will contain dot. Second step of the loop, code will contain dash. Okay, this is what is called here a comprehension list. It's like a compact way of doing loops. It's normally used to feed an array. That's why the result here is in square brackets. Hence the term of comprehension list, because the result is a list. But it's a list that you define by some kind of code. You define how you want to feed this list. Okay, and for each element that you have retrieved, first one is the dot, second one is the dash here, you send the element. So once again, for letter A, first step of this loop, code will be dot, then you will be able to send a dot, string dot. And then with this you send a good signal. Okay, each time you send a letter, send a sign, sorry, after you have sent all the sign of the letter, you just sleep for the letter separator time, yeah, which is defined in the speed class. And for sending a word is the same principle. So you will loop this time for each letter in the word, and of course for each letter in the word you call the sendLetter function. And after that you can sleep during the word separator time. And that's it, you have all the functions to send what you need. We know that we will need to feedback. We want to send color code depending on the average. Okay, so this is a parameter I call score here. It will be a percentage. If score is above 70, sorry, I send green. If it's above 50 and under 70, I'll send orange, and below 50 I send red. Okay, that's it. So we start here with the initializing our points and our atoms, number of atoms which will be updated inside the loop, of course, and which will allow us to update the average through the score to color here function. As we saw earlier here, before starting to loop, we will ask for the current rate. We will send the first demand to the Arduino. Hey, please send me the current state of the potentiometer. Okay. So normally the next step will be in the while loop. As soon as we receive data, this data will be first time the rate sent by the Arduino. So we can read the line, and we can compute here the equivalent in in float of the potentiometer state. I plugged it on the 5 volts, so it will go till 1023 here. So as soon as I have the rate, I can ask for an update of the rate. Okay, for debug sake here I will show the rate and the speed in words per minute. Being in the loop, I can consider that I am in my attempt, so I can increment this attempt value, and I can call getWord function to get a random word, and then I send this word. Okay, sending the word will make the LED flash the whole word. Then here I will ask for the proposal of the user, and if the proposal is equal to the word sent, then I earn a point. I can compute here the average, should be round on points on attempts, percentage. I can get the color by score to color of the average, okay, which I can send to the Arduino. Remember that in the Arduino I have messages that are prefixed with a FB, like feedback underscore color. So I will here create this message and send it to the Arduino. It will update the LED. Okay, then I can ask for the current value of the potentiometer. It will allow me to update the word per minute in the next phase of the loop. Okay, maybe let's see if it works. Yep. Okay, it's sent, and here I will launch this. So what was it? Maybe 3. Yes, I have my debug here, so my LED is green. Hope you can see it. list. Yes. So still green. We have 100%. Okay, now I will send something else. I know it's not this because it's not in the word list, but I want the LED going to orange, so maybe it's not very obvious for you. Trust me, it's orange, and if I send a wrong value again, we go to 50 and the LED is now red, the square one. Okay. This one I know I should. Bingo. Okay, well, that's it. We deserve a sip of coffee. Thank you for watching, and see you soon.